as I alluded to earlier, things do get automatically grouped when they're similar. And one of the nice parts about this are you're not dealing with all of the univariate analysis. Like take a traditional performance management platform where maybe you did catch some of these counters going anomalous just with your traditional thresholding. You probably got 5, 6, 8 alarms in your event management system that really you'd have to go into a secondary system and build some type of correlation to say, whenever I see this and this occurring together, I want to suppress these events and create one situational event or one synthetic event that might, help my NOC understand of, what was really the root cause of this particular thing, or what is potentially, something going on across these multiple events occurring. So one of the nice parts about PI is that it does that out of the box with all of its anomaly detection. If it does find something that is correlated across nodes, it does have the ability to suppress the events in a way that, from a view perspective, you're not dealing with all of the multiple metrics. And this is probably one of the more interesting scenario cases, because what we have here is we've got a set of resources that are the BOC-NT processor and the ALM-NT processor, and we're tracking user time and processor time for this particular process. And as you can see, historically, even though they're on 2 different physical servers, these things track pretty dang close to each other all the time. I mean, they're almost always in sync with what their metrics are. Now we can turn on the baseline again for any one of the metrics, and we can see that why they deviate some from each other from a baseline perspective. Really, whenever something is happening to one, we always see that something is happening with the other ones, and so we know mathematically that those things are absolutely related. There was no CMDB here or any type of helper information or enrichment given to the data to tell it that these things are similar. It was completely computed. The relationships and the grouping is completely computed by the PI system to understand that, it doesn't necessarily know what these things are, but it does know that because they are mathematically similar, they will always track together. And when they go deviant, and they have some kind of deviation, they're also kind of partially doing that together. So this user time really dropped below its baseline, but all of the other ones are also on a small downward sweep, and the icons on this particular GUI show you that, it is anomalous because it's gone outside of its expected normal values. And all 4 of these metrics did that at the same time. And even though this is the only one outside of its standard deviation, it knows that the other ones are still tracking individually on their own deviations the similar way. But it was able to group them in a way that we know that definitely there is something that is correlated between these particular resources. And we also have another anomaly here that it didn't highlight or group into the grouping for the event, because it can't guarantee that this anomaly is necessarily affected the same way, but it does notice that this same anomaly down here, this processor time on this 3rd server now, is also showing some anomalous behavior where it is actually down by the similar kind of deviation that the other ones are. And it just so happens that it's also that same type of process running on a similar kind of server. And you could turn that KP on and look and see how it plots with the rest of them. And so while it's technically down, it does rise and fall differently than the other ones do in a different pattern. So PI said, hey, this might be something you want to look at, but we're not going to guarantee that it's necessarily part of this particular anomaly occurring. But it is nice that it gives it to you in a way that lets you turn that on and off if you choose to kind of see if it's correlated. From a human perspective, where oftentimes we know from tribal knowledge some of the things you can't compute with the mathematics. But again, I think this being one of the more interesting potential metrics because of the way that the things are tracking. And how does PI really do that from a multivariate perspective? I get asked quite a lot, and what it comes down to is PI has an engine under the covers that allows it to normalize all of the metric data to a similar mathematical pattern. So you can actually put a percent in against an octet counter against a state counter, and PI will normalize all of those into a similar mathematical range where it can start tracking those standard deviations and detection of anomalies based upon not only their actual values, but their normalized values and their normalized values. And we do have the ability to look at both of those in this particular UI, where if currently we're looking at the normalization in a normalized view, we could look at the absolute values of those particular counters. And in this particular case, the absolute values are pretty similar because they're a similar type metric. But in a lot of scenarios, you could be looking at something where you've got like you said, maybe it's a ratio counter or a ratio against a counter against a state, and it really can cast all of those into a similar normalized thing. So you can view the data in a normalized way where you're not looking at a range of values on a particular plot that you get hidden in the minutia of the larger counter when you plot them together, because one is several million and one might be in the hundreds as far as our current metric, and that's kind of hard to view when one forces the other one to almost be collapsed into a non-visible state. So by normalizing the counters, it even gives you a better visual representation of how the metrics trend together and track together. Because you can get into scenarios where your absolute values are just way off of the plot's scale in order to being able to see those things in a normal kind of way. So